In this video, we're going to look at multiplication inside of RISC-V. Now the first thing to know is the instructions in RISC-V for multiplication. There are two separate instructions you need to know. Shift left logical and shift left logical immediate. Now these are two different instructions, however they mean the same thing, just with a slight difference. And it has to do with this immediate. Now when working with RISC-V, you may be curious as to why there are only two instructions for multiplication and four instructions for division. And the reason is because when dealing with multiplication, we are not concerned with the sign extension of the register. Now let's look at an example. Let's say our register T0 holds the value -7, and in binary, now in RISC-V, when dividing, you are shifting the bits to the right and inserting bits on the end. So the reason we can have 2 is because, are we concerned if the number is negative? If it is, we have to know to add a 1. If it's not, or if we're not concerned about it, we just add a 0. And we just keep shifting however many times as requested. Now in RISC-V, when shifting to the left to multiply, whatever this number is not going to affect us, whether it's negative or positive. It would stay the same. The only thing that would cause an error is if we were to multiply and cause an overflow. For example, if we shifted left all the way until this was our most significant bit, for example, we had 0, 0, 1, and that was this section, this would be an overflow because our number is no longer negative, it would be positive, which would be an overflow and incorrect. So let's go back to our example of -7. And let's shift this right. Let's multiply it by 2. And I'm actually going to write out the RISC code so you can kind of see. So assuming that T0 holds the value of -7, we want to multiply this by 2. So the way that would work is we are going to shift left logical immediate, and we're going to store the value. We can store it in T1. We're going to multiply the value that is in T0, which is -7, and we're going to multiply it by 2. And the reason we're writing 1 is because each time we shift something to the left, it's going to be multiplied by 2. For example, let's say we have the value and we know that this is 2 in binary. So if we shift this 1 to the left, going this way, that's going to bring this 1 over here. We're going to insert a 0 right here. So the new value would be 0, 0, 0, 0, 0, 1, 0, 0. So this value is 2. However, the new value would be 4. But we only shifted it over once. So what happens if we would have said 2? Well, if we would shift this over twice and the 1 ended up here, it would be the same as saying 2 times 4. So the 1 would be, this would be a 0, and this would be a 1. So it would be 2 times 4, and this spot is 8. So now our 2 has become 8 because we're saying 2 times 4. I'll make some room here. So we're asking for RISC to shift whatever's in the T0 register to the left one spot. So what we're going to do is we're going to shift everything to the left. So take all of this, send each bit to the left one, and then insert a 0. So this is going to get removed. This is our new section. So it's going to be 1, 1, 1, and then this one, 1, 0, 0, 1, 0. So this new value, and we can write it out. So this is going to be negative 128 plus 64 plus 32 plus 16, and then plus our last bit is going to be plus 2, which is equal to negative 14, which is exactly what we expect. And you can see that I forgot the 1 there. As you can see, it's what we expected the value to be. Again, it doesn't matter whether the number is negative or not, like in division, because when we are shifting to the left, the only thing we have to be concerned about is overflowing. However, whether it is negative or not does not affect the insertion of zeros to the least significant side of the register. Now, what if we wanted to multiply by an odd number, say like 3? Would we be able to just plug this in and say whatever's in T0, multiply it by 3? Not exactly, because remember, this is the shifting, and each time we shift, we multiply it by 2. So really what you're saying here is you're saying, okay, shift it to the left once, that's multiply it by 2. Shift it to the left again, okay, we'll multiply that value by 2. Shift to the left again, okay, multiply that value by 2, which is not what we're trying to achieve. So there is a little trick that we can do, and I'm going to clean up some space. And instead of negative 7, I'm just going to use the value 2. But note, if it's a negative number, the concept works the exact same. So let's say we have 2 inside of our register T0, and in binary it would look something like this. This is 2. Now, we want to multiply by 3. So what we're looking to get is 2 times 3, which would be equal to 6. So our goal is find 2 times 3 is equal to 6. So how do you think we would do this? Go ahead and pause the video and give it a shot. Okay, so we know that we want to multiply by 3, so we can multiply up to that point and then we'll stop. So we know if we shift to the left once, that would be times 2. Perfect. So let's go ahead and shift it to the left once. So we will have 0, 0, 0, 0, shift, bring this to the left, 1, 0, 0. Okay, well this value is equal to 2. So shifting it, multiplying it by 2 would set it equal to 4. So how do we get to 6 from here? And maybe you can already see it. All we need to do is add the original register that we had the value in to the resulting register from the multiplication. And we'll store it in the resulting register. And we are just going to add to T1. So right now, remember, T1 has the value 4. It has the result from the multiplication. And we are going to add the value that was in T0, which is 2. So if we're adding 2, we can just do it right here. And you can see this is indeed going to be 6. 4 plus 2. And that's a way that you can multiply by an odd number. So imagine if instead we were looking for a number times 5. And we can go ahead and do an example real quick. I'll make some room. So again, we'll say t0 is equal to 2. We want to shift left immediate. We'll store the result into t1. We're going to multiply t2 by, what do you think we need to multiply it by? We should do 1 less than the number we're trying to find. So if we're looking to multiply by 5, let's multiply by 4. And then we will add the register that we need. And we'll store it again in t1. We're going to add to t1 t0. So this is going to be, if we're looking to say 2 times 5, well, in the end we want t1 to be equal to 10. But let's walk through what it's equal to as we go through this process. So first things first, we're going to take t0, which is 2, multiply it by 4. So now t1 holds the result of 8. Okay, perfect. Going to the next instruction, we can see that we want to take what's ever in t0, add it to t1. Okay, so 2 plus 8. So now that's going to be equal to 10. And then store that result into t1. So now t1 is equal to 10, which is exactly what we were expecting. I hope you found this video helpful. If you have any ideas or suggestions, please feel free to leave a comment down below. As always, thank you for watching, and I will see you in the next video.